Hi guys, today's Leetcode daily problem is push dominoes. This question has also been asked in Bloomberg. So we are given n dominoes and initially they are standing upright. Now we have pushed some dominoes to the left and some dominoes to the right simultaneously. Now they'll start falling in the left and right direction. But and a domino falling in the left direction after 1 second it will also push its adjacent neighbor, and same thing the domino falling in the right direction will do. So the neighbor will also fall in the direction of the falling domino, but this can also happen like we have one domino where left neighbor pushes to right direction and right neighbor pushes to left direction, then the force will cancel and that domino will stand upright. So initially we are given dominoes string which tells what is the initial state, like which domino. If there is R, that means we have pushed that domino to the right direction. There is L, we have pushed it to the left direction, and if it is dot, then we have not pushed that domino. So we have to return the final state of the dominoes. Like we'll see example so that we can better understand this question. Like initially we have four dominoes. We pushed the first one in the right direction, second also in the right direction, third we have not pushed it, and fourth in the left direction. So first domino will fall in the right direction, second will also fall in the right direction, and fourth domino will fall in the left direction. But if we talk about third domino, then for this domino will push to the right and this will push to the left, so forces will cancel out and it will not fall. So we'll return final state as right dot. Also in the question it is given that a falling domino will not expend any additional force to another falling domino or already fallen domino. Now we'll see intuition. So it is very simple, like the dominoes that are pushed will always fall in the direction like in which we have pushed, and the dominoes that are not pushed they can fall also, they cannot fall, like they'll fall in the direction of the neighbor whose push reaches first, because push depends on time, like the neighbor which is nearer, that neighbor's push will reach first, so it will always fall in the direction of the nearer neighbors push. If none of the neighbors push reaches, it will not fall. Now we'll see approach. So initially we'll give magnitude of force n plus 1 to the dominoes that are pushed initially. Now this magnitude will decrease by 1 unit with distance. This we are doing because actually the force of nearer dominoes should dominate. Here also the magnitude of nearer dominoes will be greater than the magnitude of the farther dominoes. So this will act in the same way. Now we'll, for every domino that is standing still, we'll calculate right push, which is in which we'll consider the push from 0 to ith domino, right push from 0 to ith domino. And then we'll calculate left push. In this we'll calculate left push from I to n minus 1th domino, and whichever push will be greater, like with the magnitude of whichever push is greater, the domino will fall in that direction. If the magnitude is like equal, then it will stand still. Now we'll see code. So initially we have taken n equal to dominoes dot length. We have taken right vector where right of I represent the magnitude of right force considering dominoes from 0 to I, and left vector we have taken left of I represent the magnitude of left force on ith domino considering dominoes from I to n minus 1. Now if initially 0th domino we have pushed right side, so its force will be maximum, so right of 0 equal to n plus 1. Now we are just traversing in this loop to fill right vector. So if any domino we have pushed right, that means its like magnitude will be maximum, it will renew, so we'll do right of I equal to n plus 1. But if that domino is standing still and its neighbor domino has some like right value, some right force, so this domino will get force equal to the neighbor's force minus 1, as the force magnitude of the force decreases by by distance, we have already seen in the approach part. Now, if we have pushed this domino to the left side, that means its magnitude of right will be 0. After this loop is done, our right vector will be filled and will contain for each domino magnitude of right force. Now, if the n minus 1th indexed domino is pushed left initially, so it will have like maximum magnitude. So we'll do left of n minus 1 equal to n plus 1. Now we'll start traversing in loop and try to fill left vector. If any domino is pushed left, that means it's will have maximum magnitude. It's like magnitude is renewed. So left of I equal to n plus 1. If any domino is standing still, but its like neighboring domino has some left force in it, so we'll give this domino the left force of the neighbor minus 1. And if we have pushed the ith domino on the right side, so magnitude of left force will be 0. Now we are traversing again in loop to get our final state. So if the domino is standing still, so we'll calculate the net force which is acting on it. That is right magnitude of the right force acting minus left force. If net force is 0, that means this domino will stand still. If net force is positive, that is right force is greater than left force, then this domino will fall in the right direction. If magnitude is negative, that is left is greater than right, that means this domino should fall in the left direction. Now there can be other case if this we have pushed this domino already, like this domino of I is equal to R or L. So in that case, it will fall in that direction only. After this loop is done, then our answer will contain the final state of the domino. So we'll return answer. If we talk about time complexity, then we are just using some loops, and in that we are traversing from 1 to n only. So our time complexity is big O of n. And space also we are using only this right and left vector, which are storing n elements only. So our space complexity is also big O of n.